Okay, so we'll start off with number one here. At least I hope this is number one. I don't have a copy up there. All right. All right, so the equation of the line L1 is 3x equals 12 minus y. For the line L1, find one, the x-intercept. All right, so to find the x-intercept, we plug 0 in for y and solve. All right, so 3x equals 12 minus 0, which of course 12 minus 12, or 12 minus 0 is just 12. Divide both sides by 3. All right, so the x-intercept is 4. All right, now technically they probably want it as an ordered pair, right? 4 comma 0. All right, the gradient, of course, the gradient for us is just slope. All right, so I'm just going to rewrite this equation in slope-intercept form, and we would have y is equal to negative 3x plus 12. All right, so of course, the gradient is m, the coefficient of x here. So my m is negative 3. All right, a second line, L2, intersects the x-axis at the point 2, 0, and is parallel to the line L1. Find the equation of L2, giving your answer in the form y equals mx plus c. All right, so parallel means we have equal slopes. All right, so I know that my slope is negative 3. All right, then I take this ordered pair that I'm given, 2 comma 0. Now do be mindful, this is an intercept, but it is the x-intercept. It is not the y-intercept. So we cannot just use it as our c. All right, so I literally plug the x-coordinate in for x, the y-coordinate in for y, all right, and then the only thing I have left is c, so now I can solve for c. Of course, negative 3 times 2 is negative 6, so I just add 6 to both sides. All right, so now I know my m, I know my c, so I can rewrite this as y equals negative 3x plus 6. All right, C, calculate the y-intercept of L2. Well, that's silly to ask you to calculate it. Why would I really worry about calculating it? All right, of course, the y-intercept of y equals mx plus c is just my c. So my y-intercept is 6. So c equals 6. So that means my y-intercept is 0 comma 6. Now, could you plug in 0 for x and solve and get y equals 6? Sure. And then you'd have 0 comma 6 either way. But when we already have it in slope-intercept form, not really much of a reason. All right, so that was very straightforward Algebra 1. Any questions or concerns there? Okay. All right, the diagram shows the straight line L1, which intersects the x-axis at the point A, coordinates 5, 0, and the y-axis at B, coordinates 0, negative 6. All right. So first, write down the coordinates of M, the midpoint of line segment AB. All right. So to find the midpoint of any line segment, we simply take the average of the x's and the average of the y's. So M is going to be 5 plus 0 over 2, comma, 0 plus negative 6 over 2. All right, of course, simplifying that down, we get 5 halves. If you want to write it as 2.5, that's fine, comma, negative 3. All right, B, calculate the gradient of L1. All right, so our formula for the gradient, our slope formula, all right, is y2 minus y1 over x2 minus x1. All right, so in this case, we have -6 minus 0 over 0 minus 5. All right, so that is negative 6 over negative 5, which is simply 6/5. All right, so there's A and B. All right. A new line, L2, is parallel to L1 and passes through the point -1, -3. Find the equation of L2 and give your answer in the form y equals mx plus c. So again, right, we have y equals mx plus c. My y is -3 equals my m, since it's parallel, we know that it has the same m as L1, which is 6/5, times the x, which is -1, all plus c. Okay, so now we have -3 equals -6/5 plus c. All right, so I'm going to have to add 6/5 to both sides. But in order to do that, I'm going to need a common denominator. So if we think of that as 3 over 1, of course, we multiply numerator and denominator by 5. So we're going to have -15/5. All right, I'm adding 6/5 to both sides. And that's how I get my c. All right, so doing this, -15/5 plus 6/5 is -9/5. All right, so now I have my m up here. I have my c down here. All right, so y is equal to 6/5 x minus 9/5. All right, so again, very straightforward algebra 1. Okay. Next question here. The equation of line L1 is y minus 3x plus 5 equals 0. All right. For line L1, find the intercept and the gradient. All right. So I will go ahead and rewrite this in slope-intercept form just to make my life easier. So we will have y is equal to 3x minus 5. Right, so that gives me my gradient right away, right? That's just the coefficient of my x here, which is 3. All right, to find the x-intercept, we plug 0 in for y and solve. So 0 is equal to 3x minus 5. I would add 5, divide by 3, right? So x is equal to 5/3. So again, as my intercept, that would be 5/3, 0. A second line, L2, intersects the y-axis at point 0, 2 and is parallel to L1. All right, find the equation of L2 and give your answer in the form y equals mx plus c. All right, now, if we notice that this is actually the y-intercept, right? 0, some number is a y-intercept. So 2 is just going to be my c, right? Since it's parallel to L1, I know that it has this same slope of 3. So I don't really need to do any extra work here. This is just y is equal to 3x plus 2. A third line, L3, passes through the point Q, coordinates 3, 1, and is perpendicular to L1. Find the gradient of the line of L3. All right, so perpendicular is our opposite reciprocal, right? So if my original slope of L1 is 3, then my slope of L3 would be -1/3. All right, find the equation of L3, giving your answer in the form ax plus by plus d is equal to 0. All right, so I'm going to start with my y equals mx plus c. All right, I'm going to plug in my x and y and my m. So my y is 1, my m is negative 1/3, my x is 3, and then plus c. Of course, negative 1/3 times 3 is just negative 1. So if I add 1 to both sides, 2 is equal to c. All right, so now I know that in slope-intercept form, my equation is y is equal to negative 1/3 x plus 2. All right, but I want it in this ax plus by plus d equals 0 form. So I'm just going to move everything over to the left side, all right? Or you could just move the y over to the right. So that's actually the least amount of steps, doesn't really matter. But I like positive leading coefficients, so I'm going to go ahead and add. So this would end up being 1/3 x plus y minus 2 is equal to 0. All right, so I simply added 1/3 x to both sides and subtracted 2 from both sides. All right, however, we do have to be careful here at the end where it says a, b, and d must be in the set of integers. All right, integers are whole numbers. All right, 1/3 is not an integer. All right, so I need to make it an integer. Well, how about I just multiply both sides of my equation by this denominator, which is 3. If you have multiple denominators, right, you would kind of have to find like the least common multiple and multiply that, multiply everything by that number. All right, so multiplying out here, we just get 1x plus 3y minus 6. And of course, 0 times 3 is still 0. So we are done. It is now in ax plus by plus d equals 0 form, where all of my coefficients are integers. All right. So again, I know it's been a long time for us, but that is just straightforward algebra 1, right? Like stuff that you guys were doing in 7th grade. All right, the straight line L1 has equation 5y minus 2x equals 12. The point P has coordinates 4, 0. Give a reason why L1 does not pass through point P. All right, so the whole idea of this, right, is that any point that is on this line, if you plug in the x and y coordinates, it will give you a true statement. All right, so all you have to do here is plug in x and y. So 5 times 0 minus 2 times 4 equals 12. 5 times 0 is 0. Negative 2 times 4 is negative 8. Does negative 8 equal 12? No. All right. So we can say from here, so the point 4, 0 is not on L1. That's called a contradiction when you get something that is a false statement. All right. Here, B, find the gradient of L1. I would simply manipulate this to get it in y equals mx plus c. All right, so first I'd add 2x to both sides. So 5y equals 2x plus 12. All right, then divide everything by 5. We get y. All right, so y is equal to 2/5 x plus 12/5. So of course now my slope or gradient is simply the coefficient of x here. All right, so my m is 2/5. All right, moving on. L2 is a line perpendicular to L1. The equation of L2 is in the form y equals mx plus c. Write down the value of m. All right, so I know that m is simply the opposite reciprocal of the slope of line 1, since it is perpendicular. So m is going to equal negative 5/2. All right, just opposite reciprocal. Flip it, change the sign. All right, the line L2 passes through P, all right? Find the value of C. So again, if I have y equals mx plus c, right? Since we know it passes through P, that gives me coordinates 4, 0, all right? So my y is 0. My m I know is -5/2. My x is 4, and I don't know c. All right, -5/2 times 4 is -20/2. All right, -5/2 times 4 is -20/2, which is -10, right? So 0 is equal to -10 plus c. We just add 10 to both sides. C is equal to 10. And they didn't ask us to write the equation of the line or anything, so we're done there. Again, more just kind of direct application of remedial algebra 1. Apparently, I put entirely too many linear problems on here. These are all super easy, right? So the equation of line L1 is 3y minus x minus 5 equals 0. The line L1 is shown on the diagram below. The point K has coordinates 4, 3. The point T has coordinates 2, -3. The point M is the midpoint of TK. Calculate the coordinates of M. All right, so again, that's just the average of the x's and the average of the y's. All right, so M would equal 4 plus 2 over 2, comma 3 plus -3 over 2. And of course, that would simplify to 6 over 2 is 3. 3 plus -3 is 0, and 0 divided by 2 is still 0. All right, so the midpoint is 3, 0. Okay. Show that the point K lies on L1. All right, so now again, I take my coordinates of K, I plug it in for the x and y into L1, and it should, if it lies on it, it should give me a true statement. All right, so I know that 3 times y, which is 3, all right, minus x, which is 4, minus 5 should equal 0. All right, well, 9 minus 4 is 5, and minus 5 more does indeed equal 0. All right, so yes. Now you should probably write out, right, since 9 equals, or since 0 equals 0, you know, point K is on L1. On the actual paper 1 and paper 2, problems given to you like this, where they have like no room to work, all right, they'll give you an answer booklet where you actually like put all of your work and stuff. Okay, C, calculate the length of TK. All right, so again, here's my TK. All right, length, we can just use the distance formula. All right, so the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. I think the formula packet that you have, it's under prior knowledge. I think they flip these around, like x1 minus x2 and y1 minus y2. It doesn't really matter because you're squaring it, right? So if you take any two numbers, let's just pick like 7 and 4, right? Well, 7 minus 4 is 3. Well, 4 minus 7 is -3, right? So, but since you're squaring it, 3 squared is 9 and -3 squared is 9. It's not going to matter which order you put them in, right? Technically, this should be the equation because this is how you get the distance between two coordinates, but I won't get. That's what this is. This is like the distance formula is 100% derived from the Pythagorean theorem. Yep. All right. So here, all right, we plug this in. So we have the square root of 2 minus 4 squared. All right. plus -3 minus 3 squared. All right, so 2 minus 4 is -2. -2 squared is 4. And -3 minus 3 is -6. -6 squared is 36. So this is the square root of 40. All right, this is an exact answer, so this would be accepted. All right, you could plug this, like if you plugged it all into your calculator at once and hit enter and got some decimal approximation, that's fine also. Just make sure that you either write the entire thing or round correctly to 3 sig figs. All right, but the square root of 40 is 100% an exact answer, totally correct, or totally accepted, right? All right. The line L2 passes through the point M and is perpendicular to L1. All right. So find the gradient of the line L2. All right. So my gradient here, if I rewrite this, right, this is going to be 3y equals x plus 5. So if I divide both sides by 3 or multiply both sides by 1/3, all right, we would get y is equal to 1/3 x plus 5/3. So I know the slope of y1 is 1/3. All right. So since we know these are perpendicular, the slope has to be an opposite reciprocal. The opposite reciprocal of 1/3 is -3. All right. Find the equation of L2. Give your answer in the form ax plus by plus d equals 0, where a, b, and d are integers. All right, so I'll start this over here. All right, so I'm going to start with y equals mx plus c. All right, my m I know is -3. All right, we know that it goes through point M, all right, which we found to be 3, 0. So my y is 0, my x is 3. All right, of course, -3 times 3 is -9. So I would add 9 to both sides, and we figure out that 9 is equal to c. So now, all right, I know that y is equal to -3x plus 9. So that's the equation of L2 in slope-intercept form. All right, but if I want to put it in ax plus by plus d form, right, this would just be 3x plus y minus 9 is equal to 0. All right, so I'll put that here. 3x plus y minus 9 is equal to 0. Now, you also could have just subtracted subtracted y from both sides, and you would have ended up with -3x minus y plus 9 equals 0. That's totally acceptable too, right? It doesn't matter which way you do it, all right? The point N is the intersection of L1 and L2. Calculate the coordinates of N. All right, so there's a couple of ways that we can do this. All right, you can use substitution, you can use elimination. All right, I would probably just graph, right? So I already have, here's L2 in y equals mx plus c form, right? I also already have L1 in y equals mx plus c form. I could put those both into my calculator, all right, and just use the intersection feature on my calculator. So let's go ahead and do that here. All right, so in L1, I have 1/3 x plus 5/3. All right, and in y2, that way. All right, I have -3x plus 9. All right, I graph these things. I have a funky window right now. Guys, just a very convenient thing to remember, Zoom 6 to fix, right? Zoom 6 always puts you back at that standard -10 to 10, -10 to 10 window, all right? So I see that I have a nice intersection here, all right? If we hit second trace, that takes us to our calculate menu, all right? We can come down here to intersect, all right? It says first curve, so I just go to where that looks like. I hit enter again, I hit enter again, all right? And we get 2.2, comma 2.4. So 2.2, comma 2.4. All right, would you like to see me work it out algebraically as well? No? Okay. Okay. In an ecology experiment, a number of mosquitoes are placed in a container with water and vegetation. The population of mosquitoes, P, increases and can be modeled by the function P of t is equal to 24 times 4 to the 0.385 t power, where t is greater than or equal to 0. T is the time in days since the mosquitoes were placed in the container. A, find the number of mosquitoes, 1, initially placed in the container. All right. So if we're talking about initially placed in the container, how many days have passed when we first start? 0. All right. Whenever you're talking about initial amounts, your time is always 0. All right. Now, if you know anything about standard forms of exponential functions, it's always going to be this number here. All right. Really, all this is y is equal to a times b to the x power. All right. Where a is your initial amount, b is your exponential constant, right? And of course, x is your exponent, all right? But here, if you do p of 0, right, you can also reason it out without necessarily plugging it in. If I plug 0 in for t, what's anything times 0? 0. So I have 4 to the 0 with power. What's that? What's anything, any non-zero number to the 0 with power? 1. All right. So 4 to the 0 with power is 1. 24 times 1 is 24. Right. But again, this number out in front is always going to be our initial amount. Okay. And what is, how many mosquitoes are in the container after 5 days? We literally just do P of 5. All right. So this would just be 24 times 4 to the 0.385 times 5 power. All right. Again, we can just plug this right in a handy dandy calculator here. All right. So 24 times 4 to the 0.385 times 5 power. Whoa, son of a biscuit. All right. So 24 times 4 to the 0.385 times 5 power. Boom. All right. 346.08. The great thing is here, right? What are we always supposed to round to unless told otherwise? 3 sig figs, right? So 3 sig figs, this is just 346. It's a nice whole number that way. All right. It says the maximum capacity of the container is 5,000 mosquitoes. Find the number of days until the container reaches its maximum capacity. So now that's going to be my y, which is my P of t, right? So I just say 5,000 is equal to 24 times 4 to the 0.385 t power, right? Again, we can pull out a handy dandy calculator here. What can we use to solve this? Numeric solver. So math up takes us to numeric solver. All right, the left side of my equation has 5,000. All right, the right side of my equation has 24 times 4 to the 0.385 x power. I hit enter. Do remember to hit alpha enter here. All right, 10.00357. All right, so t is equal to 10.00357 ... Of course, that rounded to 3 significant figures is what? Yeah. Again, I have a feeling they did that on purpose, right? So that 3 sig figs just takes you to a nice whole number, so you didn't have to worry about it. Question? Okay. Are you sure? Okay. Absolutely. All right. Now, you also didn't have to use solver. You could have used the definition of logarithm, right? Of course, significantly more difficult, right? But still very doable. If you wanted to do that, you would start here and you would just divide both sides by 24. All right, then you would use the definition of logarithm to rewrite this as a log, which would be log base 4 of 5,000 over 24 is equal to 0.385t. And then you simply divide both sides by 0.385. Plug that directly into your calculator, and again, you would just get that number. Okay. So obviously, numeric solver, significantly easier. 27. I have no idea. I don't memorize how many questions are on any given random test. I would have to look. I'm sorry. Okay. So next question. Oliver throws a coin from the open window onto a flat horizontal ground in front of his office. All right, the path of the coin is modeled by the quadratic curve y is equal to 8 plus 3x minus 0.5x squared. Did I skip one? Like log. I had log in it. I'll just come back to that at the end. Where x represents the horizontal distance the coin is thrown, and y represents the height of the coin above the ground. All distances are measured in meters. The wall of the building lies along the y-axis. The coin starts its flight at point A, reaches its maximum height at point B, and lands on the ground at point C, as shown on the diagram below. All right, so we have this nice diagram below. All right, write the height in meters from which the coin was thrown. All right, so the height of A, right? So where I'm at in A, of course, x is the horizontal distance, y is the vertical distance, height is y. So I want to find the y coordinate of A, right? Now we have this original function here. I'm going to write it in standard form. So we have y is equal to negative 0.5 x squared plus 3x plus 8. All right. Now, it says that this is the y-axis, right? So this is my y-intercept. If I have a quadratic function in standard form, what's my y-intercept? C, right? This is y equals ax squared plus bx plus c. Of course, you could also just plug 0 in for your x's, but then everything with an x goes away, and we're left with just our c of 8. All right, so this is 8.
Does it need to be a point like 8, 0?
No, because it just says write down the height in meters from which the coin was thrown, right? So 8 meters is really, but it says in meters, so you don't even really have to label it unit-wise. All right, calculate the maximum height above the ground reached by the coin. Okay, so again, height is the y coordinate. So I'm looking for the y coordinate of point B here, which is the vertex of this parabola. All right, so there's 2 ways to do this. All right, we could find it manually. Of course, the x coordinate of the vertex is negative b over 2a. whatever you get for that, you plug that in for x here, and that'll give you the y coordinate, right? Or we can let our calculator do the work for us. Personally, I'm a proponent of option B, let the calculator do the work for you, all right? So if we go back here to our y equals, clear out anything we have in there, I'm going to put my function in here. So negative 0.5x squared plus 3x plus 8. All right, I'm going to graph this. I'm sure I'll have to play around with my window a little bit. All right, but the graph that it gives us, right, uses the y-axis as like the office building wall, right? And we don't care about going below the ground because when the coin hits the ground, it doesn't magically teleport through it, right? It stops. So the scratch. No, she is not. Do you know if Haley's?
Haley's on the field trip.
Okay. Well, the rest of my kids in my class are saying that she is on that field trip.
You should not be. I can text her.
She can. They can text her. Do you want them to text her?
I didn't see her card.
Oh, okay. Oh, well, then that's okay. If they said she's not there, then she's not there. Okay, gotcha. Yep, no problem. Mr. Wilson sent her an email saying that she wasn't there. So.
I have to see she's at home.
Okay, so here we're just going to change our window. All right. So for those of you that still aren't good with changing windows, we want to get you good at that, right? Guys, all this is, right, the x min just says how far left, right? How far left does the edge of my graph go? That's my x min. X max tells me how far right my graph is going to go, right? My y min tells me, y min tells me how low my graph's going to go. Y max tells me how high my graph is going to go. All right, so we know that we're kind of just looking at the first quadrant here, right? So I know that my x min and y min should be zeros. All right. With a 10 here, it looked like we saw where the coin would hit the ground, but it looked like we couldn't see the vertex. So I'm going to kind of jump that up to 20. This is just guess and check. That works fine. Okay. So although this graph doesn't look exactly like this, right, they just kind of have it shrunk in a little bit, but that's fine. All right. So now all I have to do is find my maximum. So I hit second trace, go down to maximum, right? Left bound. So I go somewhere to the left of where I know my vertex is. Right bound, I go somewhere to the right of where I know my vertex is. When it says guess, you can just go ahead and hit enter. All right. So my vertex is 3, 12.5. But this question was only asking about the height, which is my y. So this would be 12.5. All right, find the horizontal distance from the base of the wall to the point at which the coin hits the ground. Where is the coin going to hit the ground here? At C, right? So at this x-intercept. All right, so again, you could go ahead and use like the quadratic formula or something and try to like do that, but why? All right. Yeah, so we're going to hit second trace again. All right, 0 is the same as an x-intercept, right? So we're going to do left bound again. So I just go somewhere to the left of where this 0 is. Right bound, somewhere to the right, hit enter, boom. All right, so x is 8. Because now it's asking for the horizontal distance, which is x's. All right, so this is 8. I guess it didn't say in meters that time, so I'll say meters for it for B and C. All right. Next question. The sound intensity, D in decibels, can be modeled by the function d of I is equal to 10 log base 10 of I times I of I plus 120, where I is greater than or equal to 0. All right, I is the sound intensity in watts per square meter. A vacuum cleaner has a sound intensity of 1.6 times 10 to the negative fifth, whatever that is. What's W? Watts, maybe, per meter squared. All right. The intensity level of the calculate the intensity level of the vacuum cleaner. Okay, so the intensity level is D. All right, my sound intensity I is this. So all I have to do is plug this in for I. All right, so D is going to equal 10 times the log. Of course, I don't have to put base 10 in there because just a regular common log is log base 10. All right. So 10 log of 1.6 times 10 to the negative fifth power, all plus 120. All right, again, we would just plug this into a handy dandy calculator. All right, so we have 10 times the log of 1.6 times 10 to the negative fifth power, plus 120. Boom. 72 to 3 sig figs, 72.0. All right, which would be decibels, I guess. All right, a fire truck siren has an intensity level of 124 decibels. Find the sound intensity of the siren. So now it's giving me D, and I need to solve for I. All right, so we're going to have 124 is equal to 10 times the log of I, all right, plus 120. All right, now, all right, we could use this solving the definition of logarithm, but why would we? Yes, numeric solver, save us some time. All right, so math up for numeric solver. All right, on my left-hand side, I have 124. All right, whoops. On the right-hand side, we have 10 times the log of my variable, which in this case I always have to use x, plus 120. Enter, boom, alpha, enter, boom. So 2.51 to 3 sig figs. All right, and that is whatever this represents. Watts per meter squared. I mean, I probably wouldn't.
Or like if you just put intensity, like I put like the number and then I said intensity.
Now I know that when it says like give like the height in meters,
Right.
then you don't have to do it. But here I would do it to be safe.
Okay.
I would do it. All right. So what's this? Number 10? This is 9. Okay. All right. So the tip of a large wind turbine's blade rotates at a constant speed on a windy day. Its height, h, in meters above the ground is modeled by the function h of t is equal to 52 times the sine of 60t plus 80, where t is the elapsed time in seconds since the turbine was accelerated to its max speed. All right. A, write down the minimum height of the blade's tip above the ground. All right. Now, if you remember all of our kind of sine stuff, amplitude, baseline, all of that kind of stuff, all right, then write the amplitude the baseline plus the amplitude is the maximum. The baseline minus the amplitude is the minimum. All right. So remember, the baseline is this D. In this case, it's at the end. Sometimes it's at the beginning. All right. My amplitude is the absolute value of A, which is the coefficient of sine. All right. So in this case, my minimum would be 80 minus 52. All right, which is 28.
Wait, so how did you do that?
All right, so if we have some sine or cosine function, which looks like this, yes? And then we have our baseline, the middle of it, which is always my D, right? Well, the distance between the baseline and either the maximum or the minimum is the amplitude. Okay? Of course, the amplitude is the absolute value of A, all right? And the baseline or midline is D. Okay? So in order to get this value here, all I have to do is take D and add my amplitude, right? If I want to find the minimum, which is what I wanted to do here, I take the baseline and subtract my amplitude. Okay? Now, this stuff isn't given to you in your formula sheet, right? The formulas for amplitude, baseline, period, that kind of stuff, right? So if you don't remember them, another way to do it is, of course, the calculator. All right, we can graph this thing. All right, so 52 times the sine of 60x, all plus 80. All right. Of course, I want to make sure I'm in degree mode, which I am not. All right. Graph this thing. Of course, we're going to have to get a totally different window here. All right. So we will go my window. X-min, of course, we don't care anything. 0. I don't know. I'm going to say 12. I know why I'm picking that, but you wouldn't. It's just because it's going to be 2 periods. All right. You can just play around with that. You can guess and check if you need. Okay. A lot of times it's going to be guess and check, right? Like if you like, now I can look at equations and I can just figure it out, but that's because all of these things that I know how to do in my head, right? Whereas if you don't remember how to get amplitude or baseline or period, you're just going to have to guess and check, right? And if you can remember all those things, you wouldn't need to use the calculator in the first place. Do you know what I mean? So like I kind of know, like I'm going to get this in a lot fewer guesses than you would, right? But you're just going to have to play around with it, right? Now, 80 is a big hint, right? I know that 80 is going to be the middle of my graph. You know what I mean? Like I know the baseline. That's going to be the middle of my graph, right? So I'm just going to say 0 to maybe 120, and we'll see how that works. Okay, so I still didn't quite get the top, right? So I'm going to want to go a little bit higher here. Whoops. So 120 isn't going to cut it. I'll say 140. Well, 80 is going to be the middle of this graph, right? So if you want to see the whole thing, you're going to have to go. Okay. So anyway, it asks to find the minimum. How can we find the minimum? Second, trace minimum, right? So we go to the left of said minimum. We go to the right of said minimum. My Y value is 28. Shocker. Exactly what I got. Are you in the wrong mode? Make sure you're in degree mode. Yeah, when you clear your memory, it'll automatically set it back in radian mode, and it'll automatically turn stat diagnostics off, right? So for future reference, If you clear it, you'll want to turn those back on for this class. Okay. Find the height of the blade's tip above the ground after 8 seconds. Okay, now we can just plug 8 into this, right? However, if you already have it graphed, you can hit second trace again. See this first option, value? If you hit enter on there, you can type in whatever X value you want, and it'll give you the Y value. So 125.03332. All right, of course, to 3 sig figs, 125. All right, now I would still say H of 8, just so that they kind of think that you plugged in 8, right? So that they know that. And what did we say it was, 125? Yeah, 3 sig figs is fine though, right? So 125, I don't know, what is this in meters?
Wait, MTR.
Yeah, they just, the rest of the world spells it differently than we do. Well, they probably think that about us. All right. Find the time it takes for the blade's tip to complete 1 full revolution. 1 full revolution is period. All right. The period of a sinusoidal function, all right, is 360 over b. Technically 360 degrees over b. All right. So in this case, my b is 60, right? So 360 divided by 6 I'm sorry, divided by 60, is that what I'm doing? 60 is just 6. All right, so, and that's actually why I picked my Y max to be 18 when I picked the max, because in my head I knew the period was going to be 6. So I have 3 full periods here.
So why can't you just why can't you put it into solver? Because you have the height. And then
Now, what you could do, right, is figure out 2 heights, 2 maximums, and subtract them from one another.
wait, so
Right. You could find 2 minimums and subtract them from each other. You know what I mean? Like, that's another way to get the period. So if you wanted to do that, you could do that as well. I mean, obviously I know the formula for period, so why would I waste my time? Nope. I put it should be in your notes. We, like, when I went over all of the stuff, right? It's all in there. Yes. Yeah. The x coordinates. So like the x coordinate of this max minus the x coordinate of this max would give you that same thing. You could use the mins also, right? X coordinate of a min, subtract x coordinate of a min. Are we okay with that? So this would be, what is it, seconds? 6 seconds. Any other concerns about that particular problem? Always. Now, when we did that, when we did this in pre-cal, we typically did it in radians, so we always said 2 pi over b, right? But 2 pi in degrees is 360, so it'll always be 360. That's 1 period. That's 1 period, absolutely. All right. Next question. 2 identical water waves pass a sensor in an oceanography laboratory. As the waves pass the sensor, the depth, d, in meters, of water is recorded and modeled by the function d of t is equal to 3.21 minus 0.45 times the cosine of 24.2 t, where t is the elapsed time in seconds since the first wave hit the sensor. A, find the minimum and maximum depths of the water as the 2 waves pass the sensor. So again, I personally would do like the baseline plus and minus the amplitude, right? So for the maximum, I would do my baseline, which now be careful, the D is out front, right? So my baseline is 3.21 plus my amplitude is the absolute value of A. So do I care about this negative out here? No. All right, so plus 0.45. So my maximum is going to be 3.66. All right, the minimum, we take our baseline again of 3.21, and now we subtract the amplitude of 0.45. So that's going to be what, 0.24, so 2.76. Okay, now, again, if you don't remember how to get maxes and mins using the baseline and amplitude, what can we do? Graph it. All right, so we would go to our y equals here, right? And we will say 3.21 times, minus 0.45 times the cosine of 24.2x. Close that there. All right, I'm going to graph. All right, from my last one, my window's way messed up. Question? Yeah, you never have to ask, dude. You can just go. All right. So here, of course, we don't care about negatives. All right. So I will do, okay, so I'll do maybe 0 to 18 would be fine, right, for my x's. Again, you may have to play with this. All right. My y's, I know that my middle is 3.21, right? Sure. I mean, if you really want to, I like to see my graph a little bit closer than that. So I would probably just say like 0 to 5 or something. That should be good. Yeah. All right. So again, you can do second trace, find the maximum, second trace, find the minimum. Okay. But they're going to be these. Are we okay? All right. Okay, B. The first time after 16 seconds at which the depth of water reaches 3.5. Okay, now because sinusoidal functions just kind of repeat over and over and over again, right? It's going to hit 3.5 meters infinitely times, all right? But we want the first time after 16 seconds, all right? So now I'm definitely going to want my X value in my window to go past 16. I have it past 16, but not by a lot. So I'm going to make sure it's past 16. All right. I'll just go like 30. All right. So now I know that I have plenty of waves hitting this turbine. Okay. Now we want to know when it reaches 3.5. Well, the easiest way to do that is to go to my y equals and literally just put 3.5. It will draw a nice horizontal line at 3.5, right? So these are all of the different times at which it's going to hit 3.5. Does that make sense? All right. These ones up here are probably too early, right? Since this thing goes to 30, 50, just typed in y equals 3.5 into y2. Right? Since this is going from 0 to 30, this middle point right in here is probably about 15, right? So I'm probably going to be looking for this one right here, all right? So I'll go second trace. We'll go to an intersection. All right, I'll move my cursor until I get to this one. And then basically you just hit enter 3 times for an intersection. All right, and that's 20.253059. So to 3 sig figs, 20.3. All right. And this is seconds, of course. All right. And I'll just kind of asterisk here, used GDC. Right now, if you want any kind of chance for partial credit whatsoever, right, there's a couple of things you could do. You could kind of explain how you did it in your calculator. What I would do is draw a rough sketch. It doesn't have to be exact by any stretch of the imagination that looks like this. Do you know what I mean? And say, okay, this down here's 30 or 0. This down here's 30, right? This down here's 0. This up here's 5. And then just do a rough sketch like that. Put your line at 3.5 and then circle that spot and be like, this is the intersection. And then just write a little note. I used my calculator. This is a rough sketch of my calculator screen, right? That way they would give you some partial credit for that, like if needed. Okay. How many of these we got left? A lot. Hopefully not 4. Okay. And then I'll try to get to that one that I missed. All right. Oh, I did. It was just out of order. Sweet. Okay. So the axis of symmetry of the graph of a quadratic function has equation x is equal to 3/2. All right. Draw the axis of symmetry on the grid below. All right. So I'll do it just in a dashed line. All right. So x equals 3/2 is, boom, right here. 3/2 is, of course, 1.5. There's my axis of symmetry. Pretty tough, I know. All right. The graph of the quadratic function intersects the x-axis at the point -1, 0. So I know I have this point on here. There is a second point, Q. I'll just label this P just for fun. All right. At which the graph of the quadratic functions intersects the x-axis. Mark P, mark and label P and Q on the grid above. Okay, now we use this axis of symmetry. The axis of symmetry is a mirror for quadratics, right? So if I have a point 2.5 units to the left on the x-axis, I also have to have a point 2.5 to the right, which would be here at 4. Does that make sense? All right, so that's my Q. All right. The next says, right, the graph of the quadratic function has the equation y equals -x² plus bx plus c, where b and c are integers. All right. Find the value of b and the value of c. There's a couple of different ways you could do this. There's a hard way and an easy way. All right. The hard way is essentially you come up with like a system of equations, right, where you plug this x and y in for this equation once. You do plug this x comma y, right, the x and y into this equation again. Then you will have 2 equations with 2 variables. You can solve b and c. All right. However, with quadratics, that can be a little bit tricky. Now, what I'm going to do is just kind of, I mean, it's not really cheating, but I think of it as cheating because it's so much easier. I'm going to use these points, right? Well, if -1 is a 0, all right, then x plus 1 has to be a factor. If +4 is a 0, what has to be a factor? X minus 4. I'm just going to go ahead and multiply these out. Just go ahead and distribute them. So I'll get x squared minus 4x plus 1x is minus 3x, and then minus 4. All right. But I know that my leading coefficient is a negative. Yeah, just multiply this whole thing by -1. Right? Or just distribute a negative to the whole thing. Right? So that'll give me y is equal to negative x squared plus 3x plus 4. Bada boom. Done. All right, so that is, we know that my b is 3 and that c is 4. All right, find the coordinates of the vertex M. Right, now, of course, we know that the vertex has to be on the axis of symmetry. So what has to be the x coordinate for my vertex? 1.5, right? 3 halves. So I know it has to be 1.5. How can I get a y coordinate? Plug 1.5 into x. Absolutely. That's it. Right? So pull out the handy dandy calculator here. We say negative 1.5 squared plus 3 times 1.5 plus 4. Boom. 6.25. Right? So this would be 6.25. All right. Draw the graph of the quadratic function on the grid above. All right. So I'm going to go ahead and put my vertex 1.5, 6.25. So 6.5 is here. So 6.25 is right here. All right. What do I know that my y-intercept has to be? Say it. 4. Yeah, because here's my equation. The x-intercept just means I plug zeros in for x's, which means it's just my c, which in this case is 4. Can I use my axis of symmetry to get another point? Sure can. Right? If I'm 1.5 away from my axis of symmetry here, I keep going 1.5 more over here. Right, that's plenty of points to draw my. I know it's going to be hard on this computer, but I'm a little off, but you get it. Close enough. Good times? Great times. Had by somebody somewhere.
The 12th question was on our last study.
Perfect.
What was that like?
Not surprising, right? That's because a geometric sequence, right? Specifically the formula for our geometric sequence. Let me just.
Yeah, this question.
Oh, okay, this one.
But can you do it without half-life? Like
Sure.
that, like
Sure.
the formula that we have?
Sure. All right. Now, guys, half-life is just in like an exponential, right? So like if we have y is equal to a times b to the x power. Is this in your formula packet? I want to say it is.
Where would it be?
Not sure. No, it is not. That's sad. Unless it's in prior knowledge, but I don't think it is. Nope, that sucks. Well, that's just our standard form of a exponential function, right? One of the things we wrote down in our notes. Okay. But we'll go through this and I'll try to do it as best as I can without using the half-life formula because the half-life formula makes it so easy. Okay, so the half-life T in years of a radioactive isotope can be modeled by the function T of K is equal to ln of 0.5 over ln of 1 minus K over 100. right, where K is between 0 and 100, right? K is the decay rate in percent per year of the isotope. The decay rate of hydrogen-3 is 5.5% per year. Find its half-life. So all we have to do is put T of 5.5%. All right, now we leave it 5.5 because it says K over 100. Whenever you see this over 100, that means you don't have to worry about changing it to a decimal. All right. So we literally just plug 5.5 in here. All right. So ln of 0.5 over ln of 1 minus 5.5 over 100. Boom. 12.3 years. All right. The half-life of uranium-232 is 68.9 years. A sample containing 250 grams of U-232 is obtained and stored as a side product of a nuclear fuel cycle. All right. Find the decay rate per year of uranium-232. All right, so now I know my half-life, which is T up here, right? So I just plug 68.9 in for T. So I know 68.9 has to equal the ln of 0.5 over the ln of 1 minus x over 100. All right, what should I use to solve this? Yes, numeric solver. All right, so we use numeric solver here. Whoops, math up. All right, so we will have 68.9 and ln of 0.5 over ln of 1 minus x over 100. All right, so 1.0009 to 3 sig figs, 1.00. Yeah, for that, absolutely. Okay, now find the amount of U-232, so uranium-232, left in the sample after 68.9 years. Well, if the half-life is 68.9 years and we're waiting 68.9 years, how much of it should be left? How much? What like ratio of it should be left? How much? What does the word half-life mean? Yeah. So if we're waiting one half-life, exactly half of it should be left. So half of 250 is 125. And I'll just put that off to the side here. Half of 250. Because this is one half-life. All right. Now, after 100 years, if you don't remember the formula for half-life, you're going to have to remember the formula like the standard form of an exponential. Like you can't do this problem not knowing either. Okay. So half-life, and I'll show you why half-life really is this same thing. All right. You just kind of have to know how to do it. So half-life, all right, is I'll use A is equal, well, I'll just use what they use. All right, so we'll say Y is equal to A. B is my exponential constant, which for half-life is literally 1/2, right? If you're trying to double something, it would be 2, triple something would be 3, right? Half-life is 1/2. All right, to the x power. All right, now the x power in this case is simply my time divided over whatever my half-life is, because that's how many times we're cutting it in half. Does that make sense? So like if we're cutting it in half, like if my half-life, if I do 68.9 over 68.9, that's one half-life. That's why I'm cutting this in half exactly once. Does that make sense? All right. But really what we do is T over K, where T is the time and K is the half-life. All right. So we know that I'm starting, A, of course, is my initial amount, like we talked about before. All right, so 250 times 1/2 to the 100 over 68.9 power. So 250 times 0.5. Whoops, I need to get out of here. So 250 times 0.5 to the 100 over 68.9 power. All right, so 91.4 grams. Good times? Great times. Okay. Let's go on here. All right. A hot apple pie was taken out of the oven and left cooling on the bench. The temperature of the kitchen is 19 degrees Celsius. This situation can be modeled by the exponential function t is equal to a plus b times k to the negative t power, where t is the temperature of the apple pie in degrees Celsius, capital T anyway. Lowercase t is the number of minutes for which the apple pie has been on the bench. All right. A sketch of the situation is given below. All right. Explain why A is equal to 19. All right. Okay. Well, no. The y-intercept's 180. Right. So they're talking about this function here. T is equal to A plus B times k to the negative t power. All right. A is 19. All right. Because that's room temperature. Right? It's not like if you leave something out at 19 degrees, it's going to cool down to 6 degrees, right? It will never go lower than what the surrounding temperature is. So if room temperature, if the room is 19 degrees, all right, then the pie can never cool to lower than 19 degrees. Make sense? Okay. Initially, at t equals 0, the temperature of the apple pie is 180 degrees Celsius. Find the value of B. Okay, so I know at t equals 0, the temperature is 180. So I plug 180 in for my temperature. All right, we already know that A is 19. We're trying to find B. All right. And this is K to the negative 0 power because it told us at t equals 0. So I plug 0 in for t. So it doesn't even matter that we don't know K. What is any number to the 0th power? 1. All right. So this is really 180 is equal to 19 plus B. So all we have to do is subtract 19 from both sides. So 161 is equal to B. All right. After being left cooling on the bench for 1 minute, the temperature of the apple pie is 159 degrees Celsius. Show that K is equal to 1.15. So they're telling us what K is, but that doesn't mean you plug that in for K. We need to show that K is 1.15. There's actually a couple of different ways you could do this. You could plug that in for K. All right. But what I would do, the way I would do it, is I know that after 1 minute, so this tells me that T equals 1. The pi is 159. That tells me that capital T is 159. Right? So I could say 159 plus 19. We now know that B is 161. So plus 161 times K to the negative first power. All right. So you could just say used solver, right? But that's not great because you still kind of have to say, well, I used my calculator to do this, right? Although you wouldn't really have to. Whoops, and this should be equals, not plus. All right, so I could subtract 19 first and get 140. So then I have 161. All right, now K to the negative first power, how can I rewrite that without a negative exponent? What do negative exponents do? Yeah, what would that fraction be? 1 over, where'd my K go? 1 over K, right? 1 over K to the first, but you don't have to write that. All right, well, now we could multiply both sides by K. So 140K is equal to 161. Divide both sides by 140. Whoops, a little dyslexic there. And I'm going to guess that 161 divided by 140 is 1.15. All right. So there's one way you could have done it. You could have taken like our function, like where we just had, yeah, I guess that's really the only way to do it. Well, not really. You could have taken either of these numbers, right? T equaling 159 or T equals 1, and plugged in any two of these three and got the other one. Like you could have plugged in T equals 1 and K equals 1.5, plugged it into your calculator, and you should have gotten 159 for T. Does that make sense? So you could have done that also. Okay, so that is over there. Find the temperature of the apple pie 5 minutes after it has been left cooling on the bench. All right, so we're looking for T of 5. All right, but now I know all of my stuff, right? We know, like now, I know that A is 19. I know that B is 161. So 19 plus 161. We know that K is 1.15. And we're doing that to the negative T power. So in this case, to the negative 5th power. And we just plug that straight into our calculator. So we have 19 plus 161 times 1.15 to the negative 5th power. All right, so 99.0 degrees. All right, find the total time needed for the apple pie to reach a temperature of 30 degrees Celsius. Give your answer in minutes and seconds, correct to the nearest second. So this could be annoying. All right, the seconds part of it anyway. Okay, so I know that my temperature has to be 30, and that's going to equal 19 plus 161 to the 1.15 to the negative t power. What am I going to use to solve this? A numeric solver. Could we use definition of logarithm? Sure. Do we want to? No. All right. So we're going to go numeric solver. All right. So 30, 19 plus 161 times 1.15 raised to the negative x power. Enter, alpha, enter. All right, so 19.20057 All right, so I know that it's 19 minutes, right? So I think I actually put a wrong thing up here at some point. Nope, no, I didn't. All right, so I know it's 19 minutes. How can I turn this into seconds? All right, well, I know that 0.20057, technically you could do the whole thing, but this should be sufficient. All right, over 1 has to equal what over 60? Right, so really all I do is multiply that by 60. Just multiply that by 60, right? So 0.20057. So 0.20057 times 60.
So 12.03.
So 12 seconds. No, I said to the nearest second. I said to round this to the nearest second in minutes and seconds, right? So this is going to be 19 minutes, 12 seconds.
This is a lot harder than I thought.
Right? Some of them are, right? I mean, like those first 4 were all, 7th grade math. We have one left in 2 minutes.
Let's go.
No,
We don't have time.
what's wrong with you?
We don't have time. We don't have 19 minutes and 12 seconds.
All right.
Such for the people who are to watch the hour and a half long.
Okay.
Honestly.
The subscription fee for an online project management software by AB Tech is $40 per month. If the consumer buys for a whole year in advance, a discount of $130 is applied. This can be modeled by the following function, P of n, which gives the total cost when paying annually for the subscription. So P of n is equal to 40n minus 130 for n greater than or equal to 12. All right, find the total cost of buying a subscription for 2 years. All right, well, 2 years is 24 months. So we simply find P of 24. All right, so 40 times 24 minus 130. $830. All right. Find P inverse of 1790. All right. Well, guys, remember inverses are just you're switching x's and y's. So plugging an x value into the inverse is the same as setting the original function, plugging that number in for y, right? So I can really just do this by saying 1790 has to equal 40n minus 130. So if we just add 130 and divide by 40, so 1790 plus 130, divide that by 40, and we get 48. So 48. This whole thing here would equal 48. All right, the subscription price for a different online project management tool by YZ Tech is $35 per month. However, customers can only purchase annually in advance, and there are no discounts. The total subscription cost of YZ's Tech software is less than AB Tech software when n is greater than k. Find the minimum value of k. All right, so basically they're saying that here, since you're paying $30 $35 a month, all right, here, right, and you're paying $40 a month, but you get this minus 30 right off. They're saying, okay, when does this actually become cheaper? All right. Now it's kind of easier to kind of draw a little sketch of it yourself, right? So think of just the graph, 40n minus 130. So a y-intercept of negative 130 and a slope of 40n. All right. Then this other one is 35n, essentially, right? So we have a y-intercept of 0, but a slope of 35. You know what I mean? So this is cheaper for a while, all right? But then eventually, AB's text is cheaper at first, but then eventually if you subscribe enough times, right, for long enough, then this one becomes lower, because whichever one is lower on the graph is cheaper, right? So I would just set them equal to each other. So I would say 40n minus 130 is equal to 35n. Solve this equation, all right? So here we're going to get 5n equals 130. So n is equal to 26. So that's 26 months. So at 26 months, they're equal. So how many months until this one's actually cheaper? 27. Yeah. So my K, if you will, K is 27. Yeah, that's it.